Welcome to the AI and Telecom Meetup. I'm Chris. We are recording. This will be posted on our YouTube channel, and I'll push the link out onto Meetup or onto our Slack server and onto our Slack server after we get it uploaded. So in a little bit. Some announcements. First announcement, I've already mentioned it. We do have a Slack channel. Everybody is welcome to join our Slack channel. We're using it kind of for some general communication. I'd like to kind of see if we can start some other kind of types of dialogue. And so you are welcome to join that. I'll kind of go in a weird order. On Saturday, July 30th, we are going to do a developer's guide to AI. And
January 30th.
January 30th. I don't know what I said. January 30th. Thank you. Which is just under 2 weeks away. So Microsoft does they call it the global AI community. And there are a number of different chapters. One chapter is here in the Dallas area. I'm part of that group, and myself and a few other people, none of the other people who are part of that are on here today. I already introduced them, are going to basically lead a hands-on exercise to go through developing AI models using Azure machine learning. It's a pretty cool tutorial, but we'll do it for a couple of hours on January 30th. Next month's AI meetup, I will be posting that. I'll be putting scheduling it within the meetup here probably in the next day or two. Is going to be on a topic we've never talked about before: artificial general intelligence. There's been some questions about it, so we're going to talk a little bit about what is it. Where is it from a development perspective, and kind of what will it give us? And then lastly, outside of the scope of kind of any meetups, I have the privilege of moderating a panel with Intel on January 27th, next week. It's at the very convenient 11 a.m. Central European time. So KV is excited about that. But for us here in Central time, this is a nice 4 a.m. Tim, you're on your own. But this is going to be a panel session basically talking about kind of the state of AI and how it's moving forward. Open to the public. You can see the link here in the slide. If you are interested in knowing more, please feel free to reach out to me. You can reach out to me on Meetup. You can reach out to me also via our Slack channel. I'm more than happy to send you any of these links. Okay, enough of that. Let's get into what we want to talk about today. So what we're going to talk about today is edge computing. And edge computing is a topic that we have talked about in the meetup in the past, but it's been over 2 years since we talked about it. And so I thought it would be good to bring it up again. And so our simple outline for today is we're going to start with a discussion on what is edge computing. Why is AI important to edge computing? And then lastly, a little bit of edge use cases. Now, what gave me the kind of the idea to talk about this, it was after we did our meetup last month on kind of the top 10 things, at least from my perspective, that were in the Gartner hype cycle, and talking a little bit about the Gartner hype cycle. Edge computing was one of the key things. As a matter of fact, here is the Gartner hype cycle. You can see the link. You can if you just Google AI hype cycle Gartner, you'll find this link pretty easy. But what I wanted you to see is edge AI is really kind of here at the top. So it's starting to transition from what Gartner refers to as this peak of inflated expectations, and that's really their kind of I think campy way of saying we've started to get through the hype, and we're now getting to the reality, and it's starting to move into what they refer to as this trough of disillusionment, which is really basically it's not living up to the hype. But as we start to get into this slope of enlightenment, it starts to become more common and more valuable. And so we're starting to see edge starting to make that transition. It's still kind of in that inflated hype stage, but we're starting to see more and more use of that term. And that's kind of the motivation for us talking about edge today. So what is edge computing first? Before we talk about AI and edge, what is edge computing? And the purpose of edge computing is really to do two things. And I think that both of these things are very, very important. The first thing that's very important is we're going to put servers more remotely located, closer to where users are. Now, I'm in the wireless industry, so a lot of our training is wireless based. You'll see a lot of wireless type examples. It doesn't necessarily need to be wireless. What's important is that you have users and you have a server that is geographically close to those users. That's really the heart of edge computing. And a term that's used quite a bit is something called MEC. And MEC stands for multi-access edge computing. So think of edge computing as being more of a concept and MEC as a specific implementation. And we're going to actually look at another implementation a little bit later. So that's really the purpose of edge computing, trying to put servers geographically close to users. Now, why? Why would we want to do that? Well, the reason we want servers there is not so much for the server. That's kind of the kind of a what we need to do to put our applications there. That's really what I'm trying to get to, not saying it very well. So one of the reasons that I want to have some type of an edge server is so that I can have my applications more geographically close to my users. Okay, that's cool. We'll get to why that in a second. Also, I might have content that I want to have geographically close to my users. And when I talk about content, there's a number of different types of content. One type of content might be kind of a content distribution network if I'm dealing with some type of a streaming video type of service. But why? Why would I want to have applications or content closer to my users? Jump in the chat. Help me out here. I'm interested to get your thoughts on that. So Adam has one of the biggest reasons, delay. He said lag. And then Michael has response time, and Tim also has speed and customer experience. And so and so we have privacy and transport. Okay, and that's good. That's two other ones. So really so far, let me go to here. So far, we have really three basic things, and I want to talk about all three of these. So we have delay, we have privacy, and we have transport or bandwidth. And those are a good set, right? And when we see some other ones in here. So Sai is saying a quick turnaround for decisions. Okay, that's kind of in the delay And he also has the lack of a network, so minimizing the network needs, privacy. And then Josh is also putting in there not needing to backhaul unnecessary data. And those are all great answers. And that's exactly it. So delay, what we're really trying to say is I have an application. So when I think about delay, I think about that application. I have an application that I need it to do something with data that I, the user, am giving it and give me a response in a quick enough amount of time. Privacy, I've got data and I want to minimize my risk, minimize my attack surface where people could access that data. In an enterprise space, that's a very good thing. And then when we talk about transport, this is typically some type of content so that I can minimize the amount of traffic I'm having to send. Now, another way we can think about this transport is this. I want to have my application close to my data. So how do I get my application and my data close to each other? Well, I can take my data and move it to where my application is. Okay. But if I'm dealing with terabytes of data, that can be challenging. Or I can take my application and move it to where my data is natively located. And again, that's a good example of edge computing. If I'm dealing with a server that's taking all of the sensor data from a factory and it has a server at the factory, if I could put my application at the factory, I don't have to send all that data up to some type of a cloud. Okay, so good summary. Now, for those of you who have kind of a wireless slant, this multi-access edge computing node, this edge computing server that we're talking about here, and I say server, I really should say servers. This could be used for something else. This could be used for some other type of operator application. It could be used for some type of 5G application. It could be used for some type of a ORAN type of a scenario where it's being used for a virtualized radio access network type of environment. So these servers could have multiple purposes. So that's kind of that basic starting point I wanted us to start with here is what edge computing is all about is putting those servers where they're geographically more relevant. Now, if we think about a server for a second, there's a couple of things that I think are important with respect to kind of the nature of these servers. And so we have kind of compute capabilities, compute. We also have kind of the needs of that server. So the environmental, um, air conditioning type of needs is what I'm trying to get to. So there are some people who are building products that don't need to be in a traditional server center. They don't need to have the air conditioning. They don't need to have the raised floor. They don't need to have the hot aisle and the cold aisle. Some are not. And so, and my capabilities, my processing power of that server may be dictated by some of these environmental needs. But HPE and Dell, all of these major server manufacturers are producing edge servers, and sometimes they're specialized form factors. HPE has something called EdgeLine, and I saw a demo of that a couple of years ago, 2019, when I went to the GPU technology conference, and it was not that big. I mean, it was a cube, and it had basically the equivalent of 8 servers in this cube. And it was designed so that you could put it in a remote location. Others are designing them bigger to where they have more of the environmental protections. You could keep them outside. So I think that's an important thing. When we talk about edge computing, one of the biggest challenges is how much compute capability do you have and where can you put it? And we've already talked about some of the main benefits: latency, bandwidth, location aware. KV has next generation radio networks control to maximize the performance using AI. Radio intelligent controllers will be deployed at the edge. Absolutely, KV. I agree with you 100%. And so KV is kind of taking us down that path we want to go. So let's go ahead and go there. So edge computing is important before we even start talking about AI. There are a lot of people who are wanting to deploy many different services in some type of an edge computing. Probably the biggest is looking at something like a virtualized RAN. But we want to focus on AI, and KV is kind of leading us down that AI space, that AI path. So I want to start with at least a little bit of a background. And for those of you who've been part of the meetup for a while, you've seen this slide because I present it pretty much every time I present. But I want to talk a little bit about this AI automation lifecycle. And really, there are 3 things that I want to highlight briefly before we go into kind of a discussion on why AI and edge is valuable. So the first thing is we need to have data. Now, that data that I'm talking about here is what's going to feed into a model so that we can do our training. This is typically done in a centralized location. This is done by data scientists. This is where we're going to look at the results of our training. Are we able to get a high accuracy? We're probably going to use GPUs, all of that. Then we need to deploy the model. And this is really the part that I think is important for our conversation today. We need to be able to deploy this model in a place that it's relevant. So this deploying the model. This is referred to technically as inference. This is where we're going to do the inference. You'll see some people talk about an inference engine. Really, it's this deployed model. And this needs to be located in a place so that when I receive data, I can do my prediction based off of that data and then whatever appropriate actions need to occur. As we've said, oops, not that one. As we've already said, this part is really in more of a centralized location. This is being done by a data scientist. This is really the building of the model itself. More than likely, depending on the capabilities of the demands of this model, it's being trained using GPUs. This is the real math intensive part of the process. But now let's look at it from the perspective of I want to deploy this model. And let me kind of give you an extreme case. This is my favorite example. If you were to pick up your smartphone and you were to try to take a picture of somebody, a box would form around their face. And then you would see the app do a focus based off of that box. So that is a good example of a simple AI algorithm. It's an algorithm to find faces in an image. Then the automation is the smartphone app doing an autofocus based off of that. So where is that deployed model? Well, the deployed model is in my smartphone. right? I want it close to where the data is. What's the data in this case? The image coming in from the camera. Now, my smartphone has the capability, it has the processing power to do this. But what if I were dealing with something else? What if I were dealing with something that didn't have that processing power? So when we talk about edge computing and AI, this is what we're really focused on, is this deployed model. I've created some type of an application. I've created a model. I've trained it in something. And then I'm deploying that someplace that's geographically close. Now, maybe what it's going to do is it's going to receive a request from a user and reply with a response. Maybe it's going to take actions on its own. Depends on the nature of the problem we're trying to solve. Now, this is a slide I borrowed from a presentation that I did with Intel a while back. And I do highly recommend attending that. It was a webinar that I did on edge computing last year. And the presenter from Intel did a great job of talking about a lot of the edge computing issues, the edge computing technology that Intel is in the process of deploying. But the reason I wanted to borrow this slide is this is a slide that Intel talks about with respect to the delay that it takes to do something. So we have our device all the way here on the left. So you can think about this as that user, right? So these devices are drawn to be more of like a computer or a cell phone, but it doesn't necessarily have to be that. It could be an IoT device. It could be some type of a custom device based off of a specific need. Now, if I were to put a server on premise, I'd have about a millisecond of delay. Just speed of light, not very far. I could send the message to the server and get a response back. Maybe as much as 5 milliseconds, depending on where it's located, depending on the air interface technology that we're using. As I start looking at something like the network edge, it could get into upwards of 40 or 10 to 40 milliseconds. You start getting into the core and into a cloud data center, you can see it goes up 60, 100 milliseconds. So the type of delay that we're talking about are these types of delay. Now, my favorite use case, this Mark Harms and I, we talk about this one all the time. This is our, I think if there was any one acronym that both Mark and I love, I mean, all acronyms are great. It's like children, right? You have to love them all. But my favorite acronym is the photon to motion delay, which is a acronym that appears within the virtual reality space, which basically says when I have a headset on, and when I move my head, what is the amount of delay before the image on that headset can change? And that's 20 milliseconds. Photon to motion delay. And if it's more than 20 milliseconds, you have a potential problem of VR sickness. What happens is your brain knows that you've moved, and photon to motion to pixel delay is what Michael McCarthy is doing. He's sending it to me. I've heard photon to motion. There may be two. I don't know if this is the same delay and then I see photon to motion to photon delay. And yeah, and Michael's also saying less than 20 milliseconds. Excellent. But really, when I move, my brain knows that I've moved, and so it's expecting the image in front of my eyes to move as well. And if that image doesn't move, it will physically make me sick. There's a process of the brain that kind of gets confused, and you get VR sickness. Now, the reason I bring that up is look at the delays that we have on this slide and think about that 20 milliseconds. So if my virtual reality application is way out here, it's not going to work. Now, you're right. One of the things that could happen is I could actually build the application into the device itself. But what does that mean with respect to the cost of that device? What does that mean with respect to the power requirements of that device? What does that mean with respect to the physical weight of that device? Whereas if I can minimize that and I could push that into the network and still keep this 20 millisecond delay, then we might have something good. Okay, so that's just a good backdrop. Mark Harms has put a Qualcomm article in the chat. Qualcomm has a lot of great stuff in this space. And so I haven't read that particular article probably, but I'm pretty sure it's going to have some good information.
Hey, Chris, just to diverge for 1 second.
Yeah, please, Mark, please.
One other quick point I think that I've heard different people talk about as far as edge, and you could argue whether this is mech or not, but is moving all the way to the on-premise edge makes me less reliable on network connectivity. So we talked about the 3 reasons that you mentioned, but it also maybe makes me a little more independent. If the network is down for one reason or another, there might be some basic functions that I might be able to continue to perform and not rely on that network connectivity. So think of a hospital that has different equipment, and I want to do some edge AI computing on that. I could do that within the hospital itself and continue to do that even though my connectivity externally is down. And then when the connectivity externally comes back up, I can move that out into the network so that I can have more um, um, data or collect the data or whatever. But sometimes that independence is something. And here you mentioned the on-prem edge, and I just thought it was worth mentioning that that allows for that.
I think that's a great point. And really the key thing I think Mark is bringing up, and I kind of keep going back to this a lot, because when we talk about AI in general and when we talk about edge computing in general, they both have one common thing in my mind is what is the problem that you're trying to solve? Because depending on the nature of the problem you're trying to solve, that may change a strategy. So if I am a service provider, what I want to do is I want to deploy servers so that other people can take advantage of them. Well, that may be different than the problem that Mark just brought up, where I own a factory and I want to make sure my factory continues to operate. So I may want to put an edge node in my factory so that I'm more resilient to issues with any type of connectivity. If I'm in a hospital, I might want to do that. There was a video that I saw talking about Verizon's edge computing platform. And one of the examples they provided was a doctor doing colonoscopies. I'm at that age, so yay, yes. But what it was doing is it was sending the image up to a edge computing server, and then that was using AI to start to identify potential problems. And apparently, at least what this one study was saying is the AI was able to catch some things that the doctor didn't catch, which is really cool. And you could do them at a faster pace. Now, where is that server? Where is that edge computing server? Well, maybe that's in the network someplace. Maybe that's in the hospital itself. And that's kind of the point that Mark is bringing up. All right, cool. Let me pause for a second. Oh, sorry about that, Ashley. Let me pause for a second. Any questions, comments, thoughts about edge computing and kind of AI and edge? And really, when we think about AI and edge, what I want you to think about is just some AI application running on an edge server. And the reason that that AI application is running on the edge server is because of some need of that AI application. Maybe, like the virtual reality example we were just talking about, it's a delay reason. Maybe because the data is stored on that server and we don't want to transport that data, so we'll have the AI that does the processing of that data on that server. Both of those are good examples, and we'll look at some use cases over the next few slides. All right, excellent. Now, let me go ahead and talk about privacy just for a second, because we're not going to really talk about privacy much moving forward, but a couple of people mentioned that. And that is a very good thought, is that privacy, what we're trying to do is we're saying this data is important and I don't want this data all over the place. And so I'm going to put the data in a specific location, and then I'm going to let this AI application use that data. So edge computing and privacy is good from that regard. Okay. So let's look at some AI and edge use cases. Now, again, stealing from that same webinar last year that I did with Intel, they have a architecture called openness. And they're really trying to make kind of a play on the Loch Ness monster. And so they actually, if you were to go and look at their logo, I've got to show the logo now. The logo is awesome. I love it. I would totally wear a t-shirt with this. All right, so you can see up here in the upper left-hand corner, it's trying to have kind of a play on the Loch Ness monster, right? So I personally think that's just really cool. What openness is trying to do is it's trying to be a edge implementation. And so for those of you kind of in the 5G space, you can think of this as, if you're familiar with MEC, the MEC standards that ETSI is producing, this is a more of a open source project that would be similar to MEC. It's not necessarily following the MEC standards, but it's trying to accomplish something similar that MEC is providing. And this is something you could download and you could play with if you wanted to. But in this case, and the reason I wanted to grab this slide is that from an Intel perspective, they're wanting to use something like openness so that you could deploy that on these servers that are located wherever they're located. And then using that openness APIs, you could register a service, you could deploy a service where it needs to be deployed, you could move services. And this is an example of a case study that was done of trying to use Edge to more rapidly deploy services in their network. They're supporting, and I see this as a very common thing. We haven't talked about kind of this piece of the technology yet, but pretty much when people talk about edge computing, they do talk about it being containerized. It's not always the case. There are still a few places that they're looking at virtual machines, but typically when you talk about edge computing, you talk about putting a service in a container, because containers are typically smaller and easier to deploy and easier to move. And then that box at the bottom is just talking about all of the different types of technology that Intel's openness supports. And like I said, if you're interested in this more, there's a webinar that you can, you register and you can watch the webinar from last year. Let me give you another example. So we've talked a little bit about virtual reality, but let's think about this from the perspective of video. Now, again, a little bit outside of potentially the traditional telecom space, but that's okay. And so in my simple example, what I've done is I have taken video data and I've trained a model to do something with that data. Maybe it's identifying it. Maybe if you think of like security footage, I don't really want hours and hours of security footage where nothing happens. What I would like is I would like to store all of the data where something actually happened. Maybe it's the time when there's somebody that's there. Maybe it's the time when someone's doing something that is weird, whatever weird means. So in this simple little example, what I'm going to have is I'm going to have some device generating some type of data. Maybe this is a security footage, maybe this is social media data. Now, when it gets to this server here, what it's going to do is it's going to prepare that data in some way. Now, maybe it's going to be something as simple as transcoding. Maybe it's going to be something where it's doing some specific compression. Maybe it's going to be filtering out things that are not needed. Okay? So we need to get the data. So that's called acquisition. That may come from some type of a production studio, or it may be user-generated content. We need to prepare the data, and then we may distribute that data if we're talking about sending this to devices. Now, that distribution may have storage, session management, transportation, content, filtering, all sorts of things. In this example, what we're saying is we're going to take and encode that in many different ways so that we can better meet the needs of each of these different types of devices. Now, we could encode that up front, and this is a very common way that content delivery networks are set up, is we can encode this up front based off of these needs, or we can store it in one way and then encode it on the fly, depending on the needs of the specific application. In a traditional CDN, it is very much around encoding in all of the different variations that are possible. And that's important because that's very expensive. But let's flip this. And this is really the example that I think is of more interest. Let's say I wanted to do some video stream analysis. And so I have video that's being sent from devices. And maybe we're going to store that in a mech. And I've seen examples of this at like sporting events where I have all of these different cameras. And then what my mech, the application running on my mech is going to do is it's going to manage that video and then do any type of analytics. And so this may be high bandwidth applications. Now, based off of the needs of those analytics, maybe what I'm going to send up is just events. Maybe it's just metadata. Maybe it's just video clips where something happens. And that's going to help us both from a transportation standpoint, transporting the data. It's also going to help us from the perspective of storing that data out here within the network. So I can use, in this particular example, this AI algorithm to minimize that data. Maybe I'm looking for something very specific. And maybe I can build an AI algorithm that's going to only store information based off of a specific use case. I don't really want to go and get into some of the negative use cases of that, but you can kind of see maybe it's going to be something that's a security camera looking for a specific item that someone may be carrying or a specific type of event. And this is unfortunately kind of the society that we have today, where we're starting to see these sorts of things being talked about in schools and in businesses, just to make sure that we have some type of an early warning. Now, what I'm talking about here, though, is really an AI algorithm, right? So let me give you kind of the counter example. At Award Solutions, back in the before times when we actually worked in offices and saw people face to face and interacted with them, we all worked on the same floor of this building in North Plano. And one day we kind of looked up and saw a pipe that wasn't there the day before. So what we did is we went and looked at the security footage, and we actually saw after hours somebody walk in and climb up on a ladder and install the pipe. And it was people who were part of the management of the building. It wasn't anything that was bad, but the detection of that was me going saying, "Hey, is that pipe new?" And other people going, "Yeah, I think it is. Let's go look at the security footage." What if we could have done that in using AI? That's really kind of the point. Have AI detect that somebody was in the building after hours. A ladder was placed there. Why would a ladder be placed there at 6 o'clock in the evening? Those sorts of things. Could I take this algorithm and put it here? Absolutely, I could. Negative, transport costs. If I'm trying to provide some type of response, it also might be delay. And that leads us to really the last use case that I have, which is extended reality. Now, we've already talked about virtual reality. And where edge and virtual reality start to align is really trying to have a tetherless solution. I can put the VR headset on, but I want to minimize its weight and its power usage. Today, for the most part, if you want a true VR experience, you've got to have it plugged into a computer. Well, it's a wire and it's very short distances and you can trip on things and, if you want to have something that's truly untethered, then something else has got to do some of the processing. And that processing has to happen in a rapid enough amount of time. Really, what I think a better example than virtual reality is augmented reality and mixed reality. And if you're not familiar with the terms augmented reality and mixed reality, what's happening is you typically have some type of a device like a tablet or a smartphone. And you're using your camera, and the application is augmenting the camera image with some additional information. Now, in this example, which I like this simple example, is you can kind of imagine an augmented reality Yelp. And what it's doing is it's taking the camera and it's saying, okay, in this building here is a coffee shop, and this is a hotel, and this is a gym, and this is a restaurant, for example. Now, think about that for a second. Kind of think about the workflow of that. So we have an image. We're processing this image. We're augmenting it with this additional information, and we're displaying it for the user. Well, who's doing that image processing and augmentation? If I'm trying to minimize the power on the device, that might be in the network. This could be in an edge server. So how quickly can we receive the picture, process the picture, send a response? We talked about virtual reality having a maximum delay of 20 milliseconds. When we're talking about augmented reality and mixed reality, it could be, depending on the application, under 10 milliseconds. Because if I'm having this little flag show up and I've moved before the response comes back, the flag is pointing at the wrong thing, and that's giving me wrong information.
Hey, Chris, one quick personal comment here.
Please, Mark, please.
So the VR piece, I went to a thing called The Void, and I don't know if anyone's been to that or not, but it's a really cool virtual reality immersive experience. I just put the link there in the chat. The one I went to was in Orlando, and it was a Star Wars thing. And you put the virtual reality headset on, but you had to put a backpack on, Chris. because that was your edge computing. So you had to literally carry the compute power with you. And you went through this, it was actually a hybrid reality is what they call it, because you were actually feeling things and see, and you could feel on your feet and with your hands real objects, but in real life, they look totally different than what you were seeing with your goggles on. So I got to fight against Star Wars individuals and what have you, and it was a lot of fun. They even had heat and other things. But the point is, I had to carry this huge backpack.
Star Wars individuals.
What's that?
Star Wars individuals.
Yeah, that was terrible, wasn't it?
Yeah, that was pretty bad, Mark.
Stormtroopers is what I was trying to think of, and I couldn't think of it at the time.
So yeah, yeah.
So stormtroopers, thank you, Chris. And, so anyway, I can just imagine where that instead of that backpack, I have a 5G radio. And now with that 5G radio, all the compute is either local there in the building or even in the network. And I'm having this amazing hybrid reality or mixed reality kind of experience. So just a personal note on that. If you haven't done one of those, they're worth doing once, I think. For a while, Chris, there was one here in Plano at one of the Cinemarks.
Oh, okay.
They had a Void, but if you go to thevoid.com, you'll see where they're offering that and what kind of experiences they offer.
Excellent. So I had another thought before Mark said that. I don't remember what that thought is. That's okay.
I was trying to be helpful, not hurtful, Chris.
No, it was helpful. It was helpful. All right, excellent. So that's a little bit on AI and Edge. I'll put my announcement slide back up. How secure is Edge? Great question. And so I'm going to give you kind of a simple example. Is it's as secure as the core network is. And so if you've done a good job of isolating it, right? So security, there's kind of two pieces to it. There's a physical security, and then there's a network piece. The physical security is a little bit easier to control, but the network security, how are you designing it? How are you setting up your interfaces? Are you allowing people to be able to SSH in? And so, yeah, security is a huge issue in this. But it's a great question. Better question than the answer you got. Excellent. So I do want to respect your time. Actually, I'm going to stop recording.